Bluetooth, whether it's the chatty, classy version or the energy-efficient BLE, it operates in the ever-crowded 2.4 GHz band. It tries to maintain some digital civility by hopping across frequencies, classic, or broadcasting on fixed channels, BLE. But toss a Bluetooth jammer into the mix, and it's like starting an air raid siren while communicating with someone or while others around you try to communicate. A jammer doesn't care about your wireless earbuds or smart locks or yoga playlist. It simply floods the airwaves with interference, making it virtually impossible for devices to connect and speak to each other. In more polite terms, it prevents devices in the locality from communicating. In reality, it just makes everything fall apart. Early academic work in an ETHZ bachelor thesis describes how one might discover a classic Link's hop pattern by decoding its access code and then just jam it. But the only thing that you need to remember is that jammers override the legitimate Bluetooth signals, causing a denial of service. The idea is very simple. Generate so much RF noise that legitimate Bluetooth signals are simply drowned out. It's like trying to whisper in a hurricane. Either the signal never arrives, or it's too garbled to be of any use. Classic Bluetooth jumps around like it's had too much coffee. BLE is more strategic, operating on 40 channels with only 3 used for advertising: 2402, 2426, and 2480 MHz. Want to disrupt connections? Flood those 3 with noise or fake packages and you've already won. Of course, don't actually do this. This is incredibly illegal. And this video only serves educational purposes. Classic Bluetooth's rapid channel hopping in 79 channels from 2402 to 2480 MHz at 1600 hops per second makes targeted jamming tricky. Ideally, you would predict the hopping pattern to disrupt specific links, but in practice, most jammers opt for the brute force method, flooding the entire band. BLE is far more vulnerable. Since advertising usually happens just on 3 channels, jamming them basically blocks device discovery and connection. Arduino-based jammers simply use the radio board in constant carrier or high rate transit mode, of course on 1 or more channels. A strong emission in a Bluetooth channel will effectively disrupt communication there. By contrast, the authentication attacks the target Wi-Fi by exploiting 802.11 frames, a different mechanism, whereas jamming is broad spectrum. A microcontroller and a $10 transceiver can get you the job done. DIY jammers often use affordable 2.4 GHz modules to transmit static or malformed packages. The NRF24L01 is a popular option, a 2.4 GHz module radio that, with a little coaxing, a 2.4 GHz radio module that, with a little coaxing, can be turned into a jammer. Pair it with an ESP32 or even an ESP8266 and you've got yourself a functional signal disruptor. The ESP32 is particularly nice due to its dual SPI buses, letting you connect 2 radios for broader coverage. For overachievers, the STM32 Bluepill can manage up to 3 radios at once. Feeling fancy? A Flipper Zero with an NRF add-on makes for a sleek jamming platform. Tools like the Ubertooth One are better suited for analysis, but with the right firmware tweaks, they can join the fun too. If you want wideband chaos, a software-defined radio like the Hack RF or Lime SDR let you flood entire portions of the spectrum. Just remember that you'll need a power amp if you want more than a whisper. Basically, if it can transmit at 2.4 GHz, you can most definitely turn it into a jammer. Whether you should is a different question entirely. But hardware is just half of the equation. You'll need firmware to make it sing. or scream. The ESP32 Blue Jammer is a go-to solution for most hobbyists. Developed by Imensta Nougat, it supports both BLE and classic Bluetooth, Wi-Fi, and RC drones. It is actively maintained and works with just one radio module. This disrupts 2.4 GHz communications by generating noise and junk packets. Flash it via the Arduino IDE and you're set. Users even reported that it easily jams devices up to 30 meters with the stock antennas. If you like tactile buttons and blinking LEDs, RF Clown is a fun alternative. It uses two nRF24L01 modules with an ESP32 and it lets you trigger jamming with physical inputs. It explicitly supports jamming for BLE, classic Bluetooth, or both simultaneously. A button toggles these modes from BLE only, classic only, or combined. And all of this is indicated by a NeoPixel LED. Fast Jammer is even simpler. Designed for the ESP8266, it works with just one radio. It lacks classic support, jamming only BLE, but it can also jam Wi-Fi networks. It's essentially an earlier incarnation of the ESP-based jamming project. For those who prefer GUIs, NRF24_Jammer offers a sleek web interface for controlling two radio modules. It is designed as a multi-protocol jammer, disrupting Bluetooth devices, BLE technology, drones, Wi-Fi, and Zigbee. Meanwhile, BLE Jammer for the STM32 targets BLE specifically, offering surgical precision with not one, not two, but three radio modules. The design floats 2402, 2426, and 2480 MHz with rapid transmissions. Quote unquote, we will use three NRFs 24L01 plus modules and transmit a single character X repeatedly. Set data rate for 2 megabits per second for maximum bandwidth. A spectrogram in the README shows all three advertisement channels clearly flooded, so BLE scanners cannot see any other beacons. This project illustrates the best case BLE jamming strategy, but it requires extra hardware, those three radios. Popular open jammers differ in scope and hardware requirements. For example, ESP32 Blue Jammer and RF Clown cover all 2.4 GHz channels for Bluetooth Classic, BLE, and Wi-Fi, while the BLE Jammer only covers BLE advertisement channels. Fast Jammer aims at both Wi-Fi and BLE. For hardware, the ESP32 Blue Jammer and the Fast Jammer both use single NRF24L01 radios. The RF Clown and NRF24 Jammer use two radios for parallel channels, and the STM32 BLE Jammer uses three radios. More radios give you more simultaneous coverage, but at higher complexity. In case of interface, the RF Clown has a push button plus LED nodes. The NRF24 Jammer has a web UI. Most others just start jamming immediately. All are Arduino code, C or C++, flashed via the USB. For implementation, all use the RF24 Arduino library or similar. For instance, Blue Jammer's code calls radio start const carrier on each channel. RF's Clown README even lists code snippets for starting constant carriers on designated channels. The BLE Jammer sets the data rate to 2 megabytes per second to widen its jamming bandwidth. The basic principle is the same across projects. Generate RF energy on target channels.
If Bluetooth and communications pique your interest as much as it does ours, and you would like to see any of the aforementioned boards, either in this vlog or on YouTube Shorts, make sure to let us know which board is your favorite and which board you would like to see on our store. But please remember, this video is fully for educational purposes. Bluetooth jamming is a highly legal activity in most countries, and I do not condone the use of this technology inappropriately. If you're just getting into the Bluetooth mischief and only have one NRF board available, skip the nonsense and go straight to Noisy Boy for a quick install Bluetooth jammer for the ESP32. It's a lean, mean jamming machine, supporting both Bluetooth Classic and BLE straight out of the box. All you have to do is wire up your radio. You have to choose between HSPI and VSPI. These are two separate hardware SPI buses, functionally identical, just mapped to different pins. Since we're gonna be working with a single board, I'm only going to be wiring the HSPI bus. They have a step-by-step tutorial as well as a web flasher. This is how we will be installing our Bluetooth jammer. We will be going with the first option, click connect and then look for the USB port to which your ESP32 is attached to. You can do this by going into Device Manager and under the USB port. Mine is in COM6. Then we will be flashing it and waiting. By this point, your setup should be looking something like this. Now that the flashing of the firmware is completed, let's see if it detects the radio module. Well, it doesn't seem to be throwing any errors, so this means that it's good to go. Now, to access the board and actually set it up, we will first have to connect to its own web server. You can do this by connecting to the Wi-Fi network called Noisy Boy. The password was in the flasher, and it is simply Madapaka. Once you have connected to the network, you can go to its IP address 192.168.4.1. Once the page loads, make sure to reset all the saves just to clear the data from the install. Now we will go into our RF settings and we will choose HSPI. This is only because my board is wired with the HSPI bus. Since we have one single board, we're going to be putting it at single HSPI 125. This will make sure to hit both BLE and Classic, and it's single because we have one singular board. We will not touch any of the settings of the VSPI. Make sure to save every tab before continuing. We will enable the low noise amplifier for HSPI. We will set the data rate to 2 megabits per second, and of course we will put the amplifier level to the maximum. Make sure also that your payload size is big. Hit save. You can also tackle Wi-Fi networks and scan for 2.4 GHz, but we will not be tackling that in this video. Cool. Please keep in mind that using only one NRF24L01 board will not grant you a lot of area coverage nor power, hence why we have to tweak it so high in Noisy Boy.
After building one of these, your first instinct might be to, well, test it out. You're not gonna test it out, of course, in your apartment, so a forest seems like the logical place. There's no people in here and there's no devices to disrupt. Just don't do that. Don't do it in a forest, don't use it anywhere. In a forest, you might disrupt emergency beacons, safety communications, first responders, or even hikers that are up and about. It is illegal to use no matter the context or the place.
So since we went with the first option for the flashing, we have the ability to control the jamming via the boot button. Should I say it? Do you want me to say it?
Yeah, I was waiting for you to
say what? Hit it, DJ?
Yeah.
Okay. Now let's test it out. Hit it, DJ. I will now press the button. And you can see that the LED has stopped blinking. This means that the jamming is active. And well, the music has stopped. Thanks for watching.